Okay, in the last class we are discussing about this read-only memory. So, if I take the architecture of 8 by 4 ROM, read-only memory. So, we need 8 will be the output of the decoder. So, we need a 3 to 8 decoder. So, A is A2, A1, A0. A0 is LSB, A2 is MSB. There are 7 outputs Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. And 4 means we require 4 8 input OR gates. D3, D2, D1, D0. There are 8 input. Depending upon the data which is to be stored in each location, will keep the fuse intact or will blown. Suppose if I want to store in 8 locations whose address is these are 8 locations. So, in the location 0, 0, 0, A2, A1, A0. So, these bits are here I am going to store D3, D2, D1, D0, 4 bits. 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. So, I want to take store some data. You can randomly take say some 0, 0, 1, 0, 1, 1, 0, 0, say 0, 0, 0, 0, 1, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 1, 0, 1, 0, 0, 0. Suppose you want to store this data in corresponding locations. Okay. So, in 0, 0, 0 I want to store 0, 0, 1, 0. Okay. So, D3 should be 0, D2 should be 0, D1 should be 1, D0 should be 0. Okay. This is 3 to 8 decoder. So, if I give A2, A1, A0 as 0, 0, 0, then Y0 will be 1, remaining all will be zeros. Then if I keep all the connections intact, this will represent intact. This is the notation I am going to follow, and this cross represents blown, means fuse is broken. If I keep all the connections intact, then what will be the output? Because these are all 8 inputs, I have shown as single line, but all these 4 OR gates are 8 input OR gates. The inputs are connected to fuses. This is 8 input AND gate, OR gate. This is Y0 connected through fuse, Y1 connected to fuse, Y2 through fuse, Y3 through fuse, Y4, Y5, Y6 and Y7. This is y0, y1, so on up to y7. So this fuse can be programmed, this can be keep intact. If I keep intact, if this is 1 0 0 0 0 0 0 0, then output will be 1. For OR gate, if one input is 1, output is 1. Okay. So if I keep all the connections intact, then the output will be 1 1 1 1. But I want to store 0 0 1 0. Only here I want 1. So remaining 3 I want this as 0 0 0, because I want to store 0 0 1 0 in first location whose address is A2 A1 A0 is equal to 0 0 0. Okay. For that, all the connections of this D1 whose output is D1 has to be intact, whereas for this D3, the OR gate, we have to break this connection. If I don't break this connection, what happens? Output will be 1, but I want output as 0. Anyhow, the remaining inputs are zeros. Even if I keep intact, that is not going to mean produce the output as 1. The input with 1 has to be broken. Okay, you have to break this. Similarly, D2 also I want 0, so you have to break this connection. And D1 will keep as it is. D0 I have to break because I want 0. So whenever if I use 0 0 0 here, the output data will be 0 0 1 0. Now if I give the second address 0 0 1, the data that I want to store in this 0 0 1 is 1 1 0 0. So y1 will be 1, this A2 A1 A0 is equal to 0 0 1, y1 is 1. If I keep this y1 connection to all the 4 OR gates, output will be 1 1 1 1, but I want the output as 1 1 0 0. So you have to break the connections of D1 and D0 OR gates, so that D1 and D0 become 0 0. So these two has to be broken. The remaining connections are all intact. If I give this address as 0 0 1, data output will be 1 1 0 0. Similarly, for third address 0 1 0, I want 0 0 0 0. So all the connections has to be broken. And for the next address 0 1 1, A2 A1 A0 equal to 0 1 1, I want the output as 1 1 1 1. So we have to keep all the connections intact. Then for the next address 1 0 0, I want 1 0 1 0. So this Y4 output has to be broken for this D2 and D0. D2 and D0. Similarly, if I give address lines A2 A1 A0 as 1 0 1, 1 0 1, I want the data as 1 0 1 1. So the second D2 OR gate connection has to be broken. Y5 this connection. Then 1 1 0, I want to store 1 1 1 0. So the last OR gate connection has to be broken. And for 1 1 1, the last address, I want to store 1 0 0 0. So only the first connection has to be intact, the remaining 3 has to be broken. So this is about the storing of the data into the read-only memory. This will be done at the time of manufacturing itself. So this fuse has to be keep intact or blown. That depends upon the data that I want to store in the each location. Here, if I don't want to select this IC at all, so for that I can use a enable line for the decoder. There is an enable line here. If E is equal to 1, normal operation. If E is equal to 0, all the outputs y7 is equal to y6 so on up to y0 is equal to 0. Means all the outputs will be zeros. So output of the OR gate becomes 0 0 0 0. Nothing can be stored. So I can show this is a 8 by 4 RAM. Accordingly, you can draw the circuit diagram of any size of the ROM. So, I can represent this with a simple block diagram. 8 by 4 ROM means 8 by 4 ROM. What are the various signals available for 8 by 4 ROM? We have 3 address lines. Address lines will be represented by unidirectional. This is the representation of the bus A2 to A0. 3 address lines. And we have this 4 represents number of data lines. Data bus is bidirectional. So, we have D3 to D0. And then one select signal which enable, that you can call as select signal. One select signal is available to select this particular IC. If select signal is 0, we cannot perform any operation in this 8 by 4 ROM. So, the primary requirement is you have to first select this ROM, then you can perform any operation. Then we will be having read bar signal. You can read only memory. The name implies there is a signal called read bar signal. These are the various signals available for the 8 by 4 ROM. Next, we will discuss about the random access memory. RAM. Remember that read only memory. So, what are the circuitry in this read only memory? Only an array of OR gates, an array of AND gates. Inside this decoder will be having array of AND gates. AND gates and OR gates. There is no memory storage element. So, that is why read only memory is a combinational circuit. ROM is combinational circuit. And there is no feedback also. Whereas random access memory can be built by using flip flops. So, this is a sequential circuit. So, a basic cell, first we are going to discuss about a basic cell which can store 1 bit of the information. Basic memory cell which can store 1 bit of the information. So, this random access memory can also be called as read write memory. Another name for this one is read write memory. We can perform read operation as well as write operation. Okay. So, how can you write 1 bit of the information? How can you read the 1 bit of the information? First, I will discuss the basic cell. After that, using the basic cells, I can construct any big memory sizes. Okay. So, 1 bit memory basic cell will be consisting of basically SR flip flop. This is RS Q bar, and there will be one select signal to select this particular cell and there will be some output. This is read by write bar. You can perform either read operation or write operation. If this is 0, because write bar is complement, this is write operation. If this is equal to 1, which implies read operation. Similarly, you should have some input from where you can give the input data, and there will be some output from where you can read the data. This is the output where you can read the data. And there will be some input where you can give the data. So basically I have 3 AND gates, 3 input 2 AND gates. So this select signal will be common to all the gates. Similarly, read by write bar also will be given to all the inputs. This is read by write bar signal, and there will be input signal which will be connected through inverter to this AND gate and directly connected to the other AND gate. This is input where you can write the data. This is the complete 1-bit basic memory cell. We have one input signal, one output signal, one select signal, one read by write bar signal. Okay. Now the operation is, if you want to perform write operation first, I will discuss about the write operation. You can write either 0 or 1, say write 0. So write 0. So what are the different signal? The basic first thing is select should be 1, otherwise this cell will not be selected. Select should be 1. Then what about read by write bar? Because write operation, read by write bar must be 0. And to write 0, we have to make input is equal to 0. Now what happens if input is 0, select is 1, read by write bar is 0. So what happens to output Q? So for this AND gate, what are the 3 inputs? For the first AND gate, the 3 inputs are select is 1, input is 0, but after the inverter this will be 1. So this will be 1, this will be 1, and this is read by write bar is 0, after the inverter this is also 1. 3 inputs are 1. And what about this? Input is 0, so input this is 0, and select is read by write bar is 0, but through NOT gate this will be 1, this will be 1. So the output of this AND gate will be, because 3 inputs are 1, this is 1, this is 0. For S is equal to 0, R is equal to 1, what will be the Q? Reset input is 1, so output will be reset, this is 0. Implies Q is equal to 0. So Q is equal to 0 means you are writing 0. So whatever the value of the Q, that is the information that we have written into the cell. Similarly, if you want to write 1, select is 1, read by write bar should be 0, but input will be 1. If you make input is equal to 0, a 0 is written, if input is 1, a 1 is written. Now if I evaluate, Q becomes, because now this will be reverse, so the output of the first AND gate becomes 0, second AND gate becomes 1, so Q becomes 1. This is how you can write 1 bit of the information. If you want to write a 0, you take a 0 here. If you want to write a 1, you take a 1 here. So automatically q becomes 0 or 1. This is how we can write. So what about the read operation? For read operation also, so you have to read from this point output. Select should be 1 regardless of whether read operation or write operation, select must be 1. Now read by write bar should be 1 because it is a read operation. So now what happens to output of the AND gate? If q is equal to 0, already 0 is written. I want to read that 0 information. Okay. So if q is whatever this q, I want to read that q information. Q can be 0 or 1. Okay. So for select is equal to 1 and read by write bar is equal to 1. What will be the output of the last AND gate output? Output is simply ending of select, which is 1, read by write bar, that is also 1, and then q. So simply q. So if q is equal to 0, output is 0. If q is equal to 1, output is 1. So you are reading 0 information if q is equal to 0, you are reading 1 information if q is equal to 1. Okay. This is how we can read and write 1 bit of the information in basic cell. Now what are the various signals available for the basic cell? So this is a basic cell which we can use to construct the larger memories. Now I will take the block diagram of this. Instead of drawing this circuit every time, I will call this one as basic cell BC. So what are the different signals here? There will be one input signal through which we will give the data which is to be written. There will be output signal from where we will read the data. There will be one select signal to perform any operation. First of all, this cell has to be selected. Then one read by write bar signal which decides the mode of operation, read or write. Now using this basic cell, we can construct any big memories. Suppose if I want 4 by 2 RAM, 4 by 2 random access memory. So 4 locations, each location is capable of storing 2 bits. So total how many bits will be there? 4 into 2, 8. So we require total 8 basic cells. Okay. How these 8 basic cells has to be connected, I will show in the next slide. So basically here also, regardless of read only memory or random access memory, the first block is a decoder. So if I want 4 by 2 RAM random access memory, the only difference is the way in which the data is going to be stored. In case of read only memory, the data is going to be stored by programming the fuses of the OR gate, whereas here we are going to store in a basic cell which consists of flip flop. So anyhow, these 4 locations means we have to use 2 by 4 decoder. This is 2 by 4 decoder. Two address lines, A1, A0. A1 is MSB, A0 is LSB, and 4 outputs, Y0, Y1, Y2, Y3. And total we will be having 8 basic cells because 4 into 2 is total 8 bits. So we need 8 basic cells. Here 2 basic cells. This is one basic cell. We have 4 signals. Here 2 basic cells. Here 2. And here 2. Now we know that there are 4 signals. One is select signal. So the select signal of this has to be connected to the outputs. Here this Y0 has to be connected to the select of this BC as well as this BC. Okay. This is select signal. I will call select as S. Similarly, this has to be connected to select of this BC. This has to be connected to select of this BC. Here this select. Here also this will select this BC, this BC. Then we have input. Input will has to be there here. Here also this input. So there will be one common signal, 2 input signals. They are all connected together. This is one input signal. This is another input signal. There are 2 input signals. And there are 2 output signals. Connected together. This is one output signal. And this is another output signal. So these are all has to be connected together. You can connect here, otherwise you can connect here itself. So no need of this again now. I will connect here itself this. This is output of the second cell. This I will call as D1. This I will call as D0. Because data was it bidirectional. And this is for the first cell. So I will call as this one as input signals. So these 2 are the input signals. This is D1, D0. This is bidirectional data bus. Then we will be having input output select signal, read by write bar signal. Read by write bar is common to all the cells. So there is one read by write bar signal. Connect to, I am not showing that connection. Read by write signal is common to all the 8 cells. Okay. Now what will be the block diagram of this 4 by 2 RAM? 4 by 2 RAM, 2 address lines which are unidirectional, A1 A0, 2 data lines bidirectional D1 D0, one select signal correspond to each of this memory cells, select signal, then read by write bar signal. See here this D0 D1, this will be to give the data, writing of the data. So, this will be this direction, and for reading the data this will be this direction. Okay. Now, suppose if I want to store in 4×2 locations, 4 locations are there. This is the address A1 A0. Inside this we have D1 D0 data lines. So, in address line 0 0, say I want to store 1 1 any data. Okay. In 0 1 I want to store say 1 0. In 1 0 I want to store 0 1. In 1 1 I want to store 0 0. Okay. So, if I want to store 1 1, like in case of read only memory that I have explained in the earlier slide. So, if A1 and A0 are both are 0 0, A1 and A0 are both are 0 0. So, I want to store 1 1. So, if this is 0 0, what happened? Y0 is equal to 1, remaining all will be zeros. So, these 3 cells will not be selected at all. These 3 cells will not be selected at all. So, only these 2 cells will be selected. These 2 cells will be selected. So, and I have to give 1 1. You simply give 1 1 here. So, that this 1 will be written into this 1 will be written into this. Now, for 0 1, y1 is selected. Okay. So, you write here 1 0. At D0 and D1 you have to write 1 0. And similarly, if I give 1 0 address and you write this data as 0 1 at D0 and D1. Similarly, for 1 1 you write the data at D0 D1 as 0 0. So, that will be stored. And if you want to read, you can read from that output of that particular each cell. Okay. This is how you can read and write the information into 4×2 cell. This is about the random access memory. So, with this we will go for the expansion of the memories. So, we have discussed about the basic structures of random access memory and read only memory. Now, we will see regardless of whether it is read only memory or random access memory, how to extend the size. Because if I take 8086, 1 megabyte of the memory we can connect to the 8086, that is the maximum memory capacity. But if 1 megabyte of the memory IC is not available, I have only 1 kilobytes of the memory ICs, then we can connect several such 1 kilobytes of the memories to make the total memory as 1 megabyte. Okay. So, suppose for example, if I have only 1 kilobyte of the memory, so I want some 4 kilobytes of the memory, so I can use 4 such chips. Okay. So, that is what is called address expansion. So, we can expand the data also. Suppose if I have only 1024/2 memories, means 1024 location, each location is capable of storing only 2 bits of the data, but I want 1024/8, so I want the data as 8 bits. Then you have to expand the data, or you can expand both address as well as data. Okay. First I will discuss about the address expansion of the memories. Means it can be any memory, read only memory or read write memory. Suppose you will be given 8/2 memory are available, and I want 32/2 memory. how many such 8 by 2 memories are required is first question, and the second question is how to interconnect these 8 by 2 memories to make 32 by 2 memory. So, first you draw the block diagrams of both. Okay. So, I have 8 by 2 memory will be so it is direct that. So, we have 8 locations here, I want 32 locations. Okay. So, basically here this will be having the number of address lanes of 8 by 2 memory will be, it can be read only memory or random access, they have same logic. So, 8 by 2 how many address lanes will be there? The number of address lanes is equal to, we have to express this 8 as 2 raised to the power of something, that something represents number of address lanes. Normally we will have the number of locations power of 2, and this directly represents number of data lines. Okay. So, this will be having 3 address lines. So, this is A0, A1, A0, A2, A1, A0. I am writing individually instead of bus notation, A2, A1, A0. And if I want 32 by 2 memory, and this will be having 2 data lines D1, D0, one select signal. Normally chip select signal will be available as active low signal, I will call as chip select bar. Okay. So, in the previous examples we have discussed about the select as a high, but normally this will be active low signal, because inside the decoder instead of using the AND gates, normally we will use the NAND gates. If you use the NAND gate, select signal should be active low signal. So, the reason for using the NAND gates is because they are universal gates. So, this will be having some chip select signal, and read by write bar, that depends upon whether this memory is read or write memory. I am not showing that. Okay, that read by write memory signals will be available. So, 32 by 2 will be having how many address lines? We have 5 address lines, A4, A3, A2, A1 and A0, and 2 data lines bidirectional D1, D0, and 1 chip select signal available as active low signal. This is 8 by 2 memory. Okay. So, here we have 5 address lines, here we have 3 address lines. Okay. So, how many such 8 by 2 memories are required to construct this? Okay. So, we have 2 more signals extra here compared with this 8 by 2 memory. We have additional address lines are A3 and A4. Okay. So, using A3 and A4 we can have 4 combinations. So, we require 4 such 8 by 2 memories. So, I will draw 4 such 8 by 2 memories. Same A2, A1, A0 will be there, D1, D0, A2, A1, A0, D1, D0, and each one will be having its own select signal, chip select signal. This is chip select signal of this, this is chip select signal of this, this is chip select signal of the last memory. I am assuming all are active low signals. So, this all the address lines of all the 4 has to be connected together. This A2 have to connect all the A2s together, all A1s together, all A naughts together. Similarly, D1s and D naughts you have to connect together. So, this D1, D naught also you have to connect together. Now, only thing is we have to have different chip selects. We can call this as chip select 1, chip select 2, chip select 3, chip select 4. Now, if I take this 32 by 2 memory, we will be having 5 address lines A4, A3, A2, A1, A0. So, what is the starting address? Starting address will be all zeros. Then ending address will be all ones. So, if I take this first 4 locations, what happens here? This is 0 0, 0 0 1, 0 0, 0 1 0, 0 0, 0 1 1, 0 0, 1 0 0, and so on. If I take first 8 locations here, what will be this A3, A2? So, you have these extra signals. These are all common to all the 8 by 2 decoder, 8 by 2 I mean memory. These are common with 8 by 2 memory. These two are the extra signals. Okay. If I draw this total 32 combinations here, you can observe that in the first 8 combinations, A4, A3 is equal to 0 0. So, in 32 we have 4 8s. In the next 8 combinations, A4, A3 is 0 1. We can draw this 32 combinations and you can check this. In the next 8 combinations, A4, A3, A4, A3 is equal to 1 0. In the next last 8 combinations, A4, A3 is equal to 1 1. Means, so I want to store the first 8 location in the first this 8 by 2 memory, in the next 8 location in the next memory, and next 8 location in the last memory. Okay. So, for that I require again another decoder. So, I will take a decoder here. I will take active low signal Y0 bar, Y1 bar, Y2 bar, Y3 bar. This is 2 by 4 decoder. 2 inputs. I will give the 2 inputs as A4 and A3. So, between these two, A4 is MSB, A3 is LSB. Okay. If I use 0 0 here, so Y0 will be selected, means selected means 0, not selected means 1. This is negative logic. If you have this bubbles inside this, if you have the AND gate, then this logic is called negative logic. Selected means 0, not selected means 1s. If I use the AND gate, then you have to use the positive logic. Selected means 1, not selected means 0. Okay. So, here if I use 0 0 here, A4 A3 is equal to 0 0, Y0 bar is selected, Thereby for the first 8 combinations of this total 32 combinations, A4 A3 is 0. So, the first this one will be selected for the first 8 combinations. So, remaining 3 will be disabled. So, if I give A4 A3 is equal to 0 1, what happens? The second 8 to memory will be selected, and for 1 0 the next one is selected, for 1 1 next is selected. Okay. This is how we can select only one of these 8 by 2 memories for each combination of A4 and A3. Now, after selecting this particular each 8 by 2 memory, how to select the particular location in that? For that we have A2 A1 A0. If I take A2 A1 A0 as 0 0 0, and if I select this memory, the 0th location of this one will be selected. If I take 0 0 1, the first location of this will be selected. But at any time only one of these 8 by 2 memories will be selected, but A2 A1 A0 is common. Even if I give this 0 0 0, this 0 0 0 is common to this also 0 0 0, this also 0 0 0, this also 0 0 0, but the chip select of the lower 3 8 by 2 memory is 1. So, they will not be selected. Even if I give this A2 A1 A0 as 0 0 0, that 0th location of those memories will not be selected, they will be disabled. Only the 0th location of the first 8 by 2 memory will be selected, because for that chip select signal is 0. For the remaining chip select bar is 1, means chip is not at all selected. Okay. Similarly, for A2 A1 A0 as 1, only the first location of this one will be selected. Then second location, third location. After these first 8 locations, the 9th location will be selected here. From 9 to here, this will select from 0 to 7. If I start with 0 to 7, and this will select from 8 to 15. Total 0 to 31 is required, because for 32 by 2 memory we have total 0 to 31 locations, total 32 locations. So, out of this 0 to 31, 0 to 7 will be selected by the first ROM, 8 to 15 will be selected by second memory, and 16 to 23 will be selected by the third memory, 24 to 31 is selected by the last memory. This is how we can expand the address of the memories. Okay. So, what is that you have to do is, so you have to connect the address lines of all these 4 8 by 2 memories together, data lines also together, and then chip selects are different, read by write bar also you have to connect together. So, this read by write bar you have to give to all these signals, depends upon the read operation or write operation, you have to set that read by write bar signal. So, then chip select will be selected through the additional address lines of this 32 by 2, which is A3 A4. If you have 0 0, you can select the upper one, then 0 1 second one, 1 0 third one, 1 1 the last one. So, like that you can expand the address. If I take another example, suppose if I want to only construct eight by 8 using 4 by 8 memory. So, given is 4 by 8, required is 8 by 8. So, 8 by 8 you have to draw the block diagrams. 8 by 8 will be having 8 locations, each location is capable of storing 8 bits of the information. So, how many address lines will be there? 8 by 8, 3 address lines, A2 to A0 and 8 data lines, D7 to D0. And what about 4 by 8? 4 by 8 will be having two address lines, simply A1, A0 and 8 data lines D7 to D0. Okay. But how many such memories are required? This 8 is nothing but 4 plus 4. So, we require 2 such 4 by 8 memories. Another 4 by 8 memory with same A1, A0. D7 to D0, A1 and A0. So, this has to be connected here, this has to be connected together, only single bus will be available. In fact, these two also be connected to this. Similarly, data bulbs will be connected together. The only difference is we have chip select signal different. We call this as chip select 2, chip select 1. Now, this is having only one extra address line, which is A2. If I take all the 8 combinations A2, A1, A0, 0 0 0 0 0 1 0 1 0 1 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So, in the first combination 4 combinations A2 is 0, in the next A2 is 1, whereas this varies from 0 0 to 1 1, this varies from 0 0 to 1 1. Okay. So, for the first 4 combinations A2 is 0. So, I want to select this, I will connect this directly to the A2. Okay. And the next combinations I want to select the lower one. So, I will connect this to A2 bar. A2 I will connect through complement. A2 you pass through the NOT gate and you connect to chip select of the last one. So, that when A2 is equal to 0, the first 4 by 8 memory will be selected. When A2 is equal to 1, A2 is equal to 1 after the NOT gate, this A2 becomes 0. So, thereby the second 4 by 8 memory will be selected. So, after selecting this, this is first 4 by 8 memory, second 4 by 8. So, within this first 4 by 8 memory, how to select the 4 different locations? Again A1, A2 we have to change. 0 0 means first location, 0 1 means second location, 1 0 means third location, 1 1 means fourth location. Similarly, in the second 4 by 8, if we want to select the first location, A1 A0 should be 0 0, A1 A0 if it is 0 1, the first location, 1 0 second location, 1 1 the last location. So, like that we can extend the memories. So, constructing this is called address expansion. We are expanding the address and we are fixing the data. Okay. So, in the next class we will discuss about how to expand the data, and then after that how to expand both simultaneously, address and data. That we will discuss in the next class. Thank you.